So to recap, we have looked at different tools and practices which can help us in the development process. And in this video, we will focus our attention on some practices and tools which will help us write clean and elegant code. So you might be thinking, why is it necessary to write clean and elegant code, right? So I might just write some code and quickly implement the feature and ship it out, right? That is what matters, right? Why is it necessary to place so much emphasis on writing clean and elegant code? So let's reflect on this for a moment. Please pause this video and think about some reasons for why we need to write clean and elegant code. Okay, so what are some reasons? So one reason is that, as we saw earlier, software development is a collaborative process, right? And you will be working with other members in your team, and they would have to understand your code to maybe implement some other features or functionalities. And hence, it is very important that you make your code easy to understand by other members in your team. Right? And testing bugs in your code is easier, right? If the code is easier to understand for you as well as for others. Many times we write code and we revisit that code maybe after many months or even years, right? And we often forget what code we write. And if this code is not easy to understand, often at times we ourselves forget what we wrote, and this makes testing difficult even for us. And the one main reason why we should write clean code is that clean and elegant code is easier to maintain as well as extend, right? Later on, if you or others, they want to extend your code, it is easier to maintain and extend code which is clean and elegant. Okay, now that we have seen what are reasons to write clean code, so what are ways in which we can improve the quality of our code? So there is a quantitative way as well as a qualitative way. So we will look at some quantitative ways in this video, right? And this is done by using software metrics. So what is software metrics? So software metrics are a way of quantitatively measuring the complexity of our code, right? So if the code is highly complex, that in turn means it is more difficult to understand. So we will look at some software metrics in this video. Although there are several metrics, we will be focusing on a few. And there are several tools which analyze our code and give us metrics, such as the number of lines of code, the number of comments in your code, and the code's complexity. So we will be looking at one such tool known as Radon. So Radon is a tool in Python which can help us, which gives us software metrics for our code. Now, tools like Radon give us several software metrics. One such software metric is known as cyclomatic complexity. So now what is cyclomatic complexity? It is nothing but the number of decisions a block of code contains plus 1. So for example, this is a very simple max function, right, which just contains a single if. right? And the cyclomatic complexity of this is the number of decision blocks, in this case is just 1 plus 1 is equal to 2. So the cyclomatic complexity of this function is 2. So based on different constructs, the cyclomatic complexity of our code changes, right? So as we saw, if there is an if condition, the cyclomatic complexity of CC increases by 1. If there is an else if, there is another if, right? So again, the CC increases by 1. However, for an else, right, we are not introducing a new decision into our code, right? So that's why there won't be any change in the cyclomatic complexity. For the for construct and while construct, right, the cyclomatic complexity will increase by 1 because there is a decision at the start of the loop for and a decision at the while statement. So learners, here's a reflection spot for you. So we looked at this function, right, to calculate the first n primes. What do you think is the cyclomatic complexity of the first n primes function? So let's look at how we can use Radon to calculate the cyclomatic complexity of this code. So first we install Radon, right? So we can install it using the pip command, and since I already have it, it will give me some messages, okay? And now I type in Radon and I type in CC, which denotes the metric cyclomatic complexity, and I give the file name. And here the output is F stands for function, right? So first n primes is a function and it gives me a letter called A, right? And A denotes the simplest or a simple code block is referred to as A, right? And as we can see, it's a very simple code block. Now, if I want to actually know the value of the cyclomatic complexity of this function, I have to specify the option S, right? And here it tells me that the cyclomatic complexity is 5, right? So there are 4 decisions which are happening here in this code. This while loop is 1, this for is another 2, 3, and 4, right? So 4 plus 1, 5. The cyclomatic complexity of this function is 5, right? And based on our function, right, so these are different ranks which Radon gives. As we saw, ours was the CC score was 5 and hence it's a low or a simple block. And as the CC score increases, you can see that the risk of maybe introducing new bugs or trying to understand the code also increases, right? So note that this is for each specific function. And so for example, if a single function has a CC score more than 41, right? This means that there are around 41 conditions which are happening inside a single function, right? And hence this makes it very highly error prone and it is unstable, right? And the way to reduce the cyclomatic complexity is to split this function into multiple functions and do some refactoring. Now that we have seen one code metric, which is cyclomatic complexity, let's look at another one. Another software metric is nothing but raw metrics, right? So raw metrics are nothing but the total number of lines of code, right? This can include code, comments, doc strings, all of it, right? Blanks. Another type of metric is the logical lines of code. We look at what is the difference between logical lines of code and source lines of code through an example. And we have comments, right? So the lines of code plus comments plus blanks, all of this combine together to form the LOC, which is the total number of lines of code. Now let's see how a tool like Radon can give us raw metrics. So this is the same function to calculate the first n primes. Now I can use Radon and provide the option raw and call the function or call the file, right? And here we can see that it gives me LOC, which is the lines of code, is 26, right? Logical lines of code is 17, whereas the source lines of code is 18, right? So what is the difference between these two? So here in line 13, you can see that I have deliberately used the backslash symbol to split this for into two lines, right? So this is actually a single logical line of code, whereas in my source code, I've splitted it into two. And this is not considered as a good practice for short lines of code, right? And just to illustrate this example or the concept of source lines of code and logical lines of code, I have divided it into two. So hence, the lines of code are, the logical lines of code are just 17, whereas the actual source lines of code are 18, right? So if I just make this into a single line and then I run Radon, now you can see that the logical lines and the source lines of code are the same, right? Then I have 5 lines of comments, I have 3 blank spaces, 3 blank lines, right? So all of these code raw metrics are available for me to see, and it also gives me a statistic of the comments, right? So what is the ratio of the comments and the lines of code, the source lines of code? So this can give me an idea of how well commented my code is. So we can use the option raw in Radon to give us the raw metrics in our code. Now the third type of metric which we can use is known as the Halstead's metric. So Halstead's metrics identifies measurable properties in our software and the relationships between them. So for example, Halstead's metrics calculate the number of distinct operators in our code. Operators like plus, minus, division, modulo, etc. The number of distinct operands. Then the total number of operators and operands. And using these parameters, it calculates various things like the vocabulary, program length, the volume, difficulty, effort, etc. So we won't be going into the details of each of these metrics, but let's look at how Radon can give us the Halstead metrics. So we can use the option HAL and the file name, and here we can see it gives us several metrics, right? And H1 is the number of distinct operators, right? So here you can see we have a less than, line 11, 1, a modulo here which is 2, an increment here which is 3, another increment here which is 4, right? So similarly it calculates the other parameters as well, and based on H1, H2, N1 and N2 it calculates other metrics. So to summarize, in this video we looked at various software metrics like cyclomatic complexity, raw metrics and Halstead's metrics, and we saw that how we can use a tool like Radon to give us these metrics. Now let's see how we can use a tool like Radon in complex applications, right? So this code is an example of a flashcard application in Flask, right? So Flask is a web application framework, and we have, this is an example of a flashcard application. So I can see that my application folder has files called API, controllers and models. So let me just look at some metrics related to my controller file, right? So I type in Radon. I want to see the cyclomatic complexity of my controller file. So this output gives me the cyclomatic complexity for each function, right? So I see that F denotes functions, right? So each of these are functions, and I can see some of them are A, which means that the functions are small and it's not very complex. Some are B, right? So for example, the function in line number 9, which is hello, the cyclomatic complexity is 9, which is not too bad, right? But as you can see, there are several fors, and in that nested ifs are there. So these are adding to the complexity. So if functions are too complex, then it's better to split them into different functions to reduce the cyclomatic complexity. Another metric, I can just look at, what are the raw metrics in my controller, right? So it gives me the lines of code, and here you can see that the comment statistics are not that good. So the ratio of comments to lines of code is just 6%, right? And this gives me an idea that I need to incorporate, or I need to add more comments into my source file. I can also check for APIs, right? So I have my APIs function, my APIs file. Let me just check the statistics for that. Here also you can see that the comment ratio is less. So you can use tools like Radon to get a sense of how well written your code is, if your code is highly complex, if sufficient documentation and comments have been written into your code. So tools like Radon will help you write clean code.